Okay. Today is the last class. So here, today we will discuss about IEEE Reliability Test System. IEEE Reliability Test System. We will revise what we have done. So, first we discuss industry system. And we used probability and frequency and duration. For generating capacity reliability evaluation, we use probabilistic approach and frequency and duration approach. Right? And in both the cases, the risk indices were loss of load expectations, loss of demand. So what are these called? These are the risk indices. So generation capacity reliability evaluation is the foundation of reliability evaluation. So you are going to frequently see these two terms, LOE, LOE, every paper or anything. So this can be extended to micrometers also. Okay. The next part was interconnected system. Operating results. And composite generation and transmission. Right? So we used, in fact, model wise, so this probabilistic approach was model 1, and we combined this frequency duration as well as interconnected system as model 2. And this was model 3. So all these systems, they are basically generating capacity reliability because transmission systems are very reliable. So we only touched upon the transmission systems, but everything else, operating reserves, interconnected systems, everything corresponds to generating capacity reliability. So that consisted of 3 modules, right? And also we used a term known as post outage rate. Post outage rate for generation capacity reliability. But when we discussed operating results, we used the term outage replacement rate. Okay, rather than post outage rate, outage replacement rate, because results are about replacing the unit that are out. Okay. And here we use one concept known as lead time. So the time within which we can get the operating result. We have. So we evaluate reliability based on various lead times, 1 hour, 2 hour, 4 hour. So this was all about generating system first 3 modules. Then Model 5, we have decided plant and station availability. So distribution system reliability, plant and station availability, model 4 and 5 you can see. And here we used various customer oriented and load oriented such as 5P, SIB. Whereas when we say plant and station availability, we say boilers plus generators, unit plus transformers, then spares, then protection, and also auxiliary system. Right? So in model 4 we discussed distribution system reliability, which includes SIB, etc. Load oriented customer oriented indices and some load oriented indices like EMS, energy loss system. Okay. Now this distribution system reliability, this part, okay, it is very important for evaluating the effectiveness of a particular measure. For example, the government has invested say some crores of thousands of crores of rupees in creating substations, providing more transmission lines. Now, how effectively it has improved the situation of the customers? Okay. If you want to do that, then we need to use these terms. So for that, these are no meaning. This is related to mostly the plant, the generating plant. Whereas from the customer perspective, this is very important. So any study where you need to evaluate how effective some investment is. Suppose now the government is announced in government that they have already created more and more substations. So ideally that should result in various indices improvement at the customer level. Like that should be reduced power cut and hence ENS should be low. Okay. How many interruptions are there, how many power cuts are there, voltage level. So all this can be evaluated. Reliability evaluation can be done by this term. So this is a very live and relevant approach for especially distribution utilities and the government. Whereas last term plant and station availability, this is more with respect to individual plants, and we discussed that the first three generator, transformers, all those things we have discussed, given that process we have discussed. Then some concepts related to how auxiliary systems affect the derating, then how spares can be allocated, how many spares should be available, and finally how to evaluate the reliability of the protection system using a new concept of inventory and fault risk. So that thing totally we have discussed. This is the whole gamut of reliability. Okay. So now that you have got all this information, where exactly you are going to test it? Okay, suppose for your dissertation work you want to work in the reliability, then where you want to test it? For that, a popular test system is the reliability test, IEEE Reliability Test System, which is a 24-bus system. IEEE Subcommittee on Application of Reliability Methods has developed reliability test system which includes both duration and various transmission factors. It's a well-established system. The total installed capacity is 3405 megawatt. Mentioned there, you know. So what is the total installed capacity? Some salient points. What is the total installed capacity? 3405 megawatt. It's a big system, it's a huge system. Okay. Then system composition is provided in the next slide. Annual load what is provided? Okay. Annual load what is provided in terms of percentage basis. Okay, accordingly you can calculate. Okay. In terms of weekly peak loads. In terms of weekly peak loads as a percentage of annual peak. So you can choose any annual peak and you can, based on that, you can decide your weekly peak. Daily peak load cycle, so just mention before a megawatt, the annual load model. You have got weekly peak load as percentage of annual peak loads, daily peak load as percentage of the weekly peak. The right line table 2 and 3 here tables represent the appendix of our textbook, reliability evaluation, reliability of power systems textbook. Okay, Brilliant and Allen book. So they are in appendix. They have provided the details. So this tables correspond to those tables. Excel sheet versions, text versions are also available if you start the internet. Then the data in table 2 and 3 defines a daily peak load model of the 364 days with Monday as the first day of the year. Okay. Table 4, yes, weekday and weekend hourly load data. Okay. So combining tables 2 and 3 and 4, table 4 defines hourly load. So we have got for 8736 hours. Okay. Instead of 8760 hours, it provides weekdays 8736 hours. Okay. In this case, we'll see. Okay. So how many total generators? Number of units? These are taken directly from the board. You can also find Excels. So what is the total number of units? How many? 30? 32. So 32 units. So unit size varies from 12 megawatt, 20 megawatt, 50 megawatt, 76 megawatt, 100 megawatt, 155, 197, 400. Okay. FOR. Data is given. What is MTTF? Mean time to value. Lambda. MTTR? Mean time to repair. Okay. Is it lambda? MTTF 1 by lambda, right?
Yes.
1 by lambda, right? 1 by and this is 1 by lambda. Schedule maintenance. So all this data given. Right. Next, this is related to generating system. Then the major part is the load. Okay. How this system has represented various loads. So as we discussed, so for 39 weeks and continue for 52 weeks. For 52 weeks, so peak load as a percentage of the annual peak load. Suppose you decide annual peak load to be 5000 megawatt or say 4000 megawatt. Then every week these are the peak loads. You can find out 86% of that. Okay. Next, weekly peak load as a percentage of annual peak. Continue. Okay. That's it. Now you have got weekly data, weekly peak load, but what about daily load? So daily peak load as percentage of the weekly peak load. So that means Tuesday is the one having the highest peak, 100% of the peak. Okay. Got it? Then hourly peak as a percentage of daily peak. Okay. So daily Monday, you know. So for Monday, suppose you start with Monday 12 to 1 AM, accordingly you will have 67% of weekly peak, 60% of weekly peak, 50% of weekly peak, like that. Okay. And all this you can make a program. Okay. So there are programs available also. You can search in Google. Everyone who works on this, a small program you can develop so that when you change the annual peak load, automatically the load for all the hours of the year are calculated. Okay. So these are the standard results of IEEE RPS. But nowadays what people do, they integrate renewables, they integrate microgrids. Okay. With the total installed capacity is 3409 megawatt, the complete capacity model with no rounding increment, we have large number of bits. We are now familiar with only 2-3 generators, right? So we have to use 2C3, 3C2, 3C1 like that. But here there are 32 generators. So imagine what will be the number of states and the capacity size. So we have a truncated model having a cumulative probability of 10 to minus 8. The system has 1872 states. Okay. You see, there are 1872 states for the raw IEEE RPS model. Okay. Table 5 represents a set of repetitive results for the comparison purpose and capacity practice, these tables are truncated and rounded, which when converted with load models can give the resolution very accurate. So for this basic IEEE RTS, for reference, these are the yellow LED and blue LED. So note this down. So anytime you are trying to improve this or use this, you need to remember this. So loss of load expectations is 1.36 day per hour, or for hourly loads 9.39 hours per year. So that means only 9 hours per year there will be load loss of load. Then generation model data. So there are how many states? 1872 states. Okay. So here only relative states are given: state 1, state 31, state 19, like that. What is the capacity out for that state? What are the individual probability for those capacity outages? Cumulative probability corresponding to cumulative frequency. So all these things you can evaluate using the technique that you have used. Provided you need to use a digital computer. It cannot be done manually. In computer you have to do that. But the same concept you can apply. Raw concepts. Now you will see what you have learned in this chapter, reliability cost system, how you can apply to various. There are some of the papers that I have selected. The first paper is here power system reliability assessment technique and modeling approach based on quantum computing. Somebody was applied using this. And here it's very recent paper. Another one is urban grid resilience assessment framework. Leveraging electric time-based analysis and mobile distributed generators. So here you get introduced to another term of resilience. Okay. Reliability, resilience, robustness. These are the related terms. Vulnerability. Vulnerability means for any system. What is the vulnerability? How the system can fail. So when you want to defeat someone or somebody or some system, for example, somebody wants to completely hack into the system. Okay. So there he needs to find the vulnerability of the system. Then some research paper on basic reliability. This is the basic research paper by Millikan himself. So here you see, till now in our course we did not see renewable integration. This is how wind power was integrated. Okay. So you can see all this adequacy evaluation, etc. in this paper, and you can find out all those modeling. See what we are seeing here: capacity outage probability table, right? Capacity outage probability table, loss of load expectations, right? So you will see those terms, and this shows how you are going to model the wind power plants. RPS 120 megawatts of load wind power. That means 4 RPS it has indicated 120 megawatt of wind power. concept paper. Then this is optimal cycling and management of standalone hybrid photovoltaic unit system based on hydrogen storage. Everything that is in model research, but then you are evaluating and LOE. Eventually, what you are evaluating is LOE and LOE. Unless you understand the concept, you cannot. Okay. This is one better. This is how the wind power is obtained. Then you see here LOE, all these things stuff. LOE and LOE. The next one is here this is not directly reliability, rather it is computing grid resilience. How it is prone to cyber attacks or not. Okay, so that thing is usually reputed journal in electrical system and research method. There will be a journal. Yeah. Reliability evaluation techniques with the integration of wind power fluctuation. Again, the same concepts of LOE and LOE will be used here. The last one. So this is the latest one I told you. Okay, using requirement number. Okay, how are you going to evaluate reliability? See, this is how we do reliability assessment. This slide is very kind of summary of what you have learned. Reliability assessment. How to evaluate reliability of power. We can have simulation method, enumeration method, that is finding out individually the state, QC method. Okay. Enumerating component failure and system state model. Okay, that we have studied. So this is classical method, and this is simulation method is the last chapter in your textbook. We have not provided that. That is simulating various flows, and this is finally using the method that he has proposed. This paper. So you see here. So what exactly it is doing? Finding out loss of load probability, expected humanity not survive. Okay. So these are the same thing that it is calculating, but by using one. You can find out research topic if you want to work on the reliability. Okay. You stop here.